Hi everyone. Now in this video we are going to see how to construct a hyperbola when the position of a point P on it is 70 mm and 85 mm from the asymptotes. It seems like the question what we are seeing on the screen similar to the previous question, but there is a small just difference is there. That is, the asymptotes are included with an angle of 75 degrees. In the previous question, the asymptotes are perpendicular to each other. When the asymptotes are perpendicular to each other, it will be called as orthogonal asymptotes. As of now, the asymptotes are included with an angle of 75 degrees. Means when the angle is greater than 90 or less than 90, it will be called as oblique asymptotes method, remaining the procedure complete everything the same. There is no difference. Only just asymptotes are included with an angle of 75 degrees. Now let's see, while constructing some differences are there, we can find it out. If you see, this is the hyperbola by orthogonal asymptotes method. Total 16 points are there. Each and every point we saw in the previous video. And coming to oblique asymptotes, here also the same 16 points. What is the main difference? You can see that draw asymptotes OA and OB perpendicular to each other for orthogonal. Here draw asymptotes OA and OB with an included angle between each other. That is the only difference for the construction, remaining everything the same. So that's why I don't want this orthogonal. Let me close this one. Done. Now I'll go for the construction. Take a line, just normal line. This one, press tab, so the 90 degrees is there. I'll go for 75 degrees, enter. Okay, now DAN, dimension angular. Okay, DST, enter. Modify text ID is 5, symbols and arrows is 3, primary units I'll go for single precision, enough for me. Yeah, see, perfectly 75 degrees. DT. Okay, command line is missing. CO command line, so that it will benefit for you. DT, dynamic text. Okay, height as 6, rotation angle 0. This one will be O, and this is A, and this is B. Already you know that. Okay, done. Now 70 and 85 mm from the asymptotes. What I am going to do, take offset. Let me check here, 70 mm this one. Okay, the same procedure na. O 70 mm from here to here, 75 mm. Okay, now again asymptotes 85 mm. Yeah, trim this portion. Okay, so it's very small, let it make as big. We'll move it here, take a line, just draw it here, EX, extend. Okay, here also we'll do something, EX, extend. Done. Let's delete these two lines. Okay. Oh, it went. Control C, Control V. This is A. Okay. And this is switch off that to B. Perfect. So now this line is 70 mm from this one, and this line is 85 mm from this asymptote, and this is the point where the curve will pass through. Okay, P type, star mark, set size in absolute units. Let us take it as 3. Perfect. You can see the point. Okay, let's change the point type to 5 only. It looks very small. Done. Control C, Control V, P. Now everything the same, we did it. Now let's mark the points here. Point 1, point 2, point 3, point 4, point 5. We'll give the text also, so that numbering, not the text. 1, 2, 3, 4, 5. Again, we know the procedure in the previous one. Join O1, join O2, join O3, join O4, join O5. Nice. In the previous tutorial, like orthogonal asymptotes, what we did, I said that this line, just a minute, it got stuck. Yeah, first let us give the C, D, E, F. As I said that whatever the lines passing this construction O1, O2, either it should pass or cross EF or it should meet EF. These three lines crossed EF, but these two lines should meet EF. So EX, perfect, perfect. We marked this one. Let's give the text. This one as 1 dash and this one as 2 dash and this one as 3 dash, this one as 4 dash, this one as 5 dash. Perfect. We finished it now. Now what to do? We need to draw vertical lines and horizontal lines. But here see, vertical lines in the sense there, what we did for orthogonal asymptotes, we drawn this one because these are parallel to asymptotes. These lines are parallel to asymptote. This horizontal line is also parallel to the asymptotes. But here the asymptotes are different, means included angle of 75 degrees. Here we should not draw the vertical lines like this. Here always we need to draw parallel lines to this one. So that's why what I am going to do is that, see here, just one normal line, I am making it TR. Okay, now already we made this line CO, copy, specify base point, and then I am taking it to 2 dash. Okay, let me wait. You can ask me, sir, in the previous video you saw you made that object snap tracking easily we can do it. No, object snap tracking will works for the 90 degrees, not for any angle. That's why I am going with the trim option only, 1 dash and 2 dash. And now what I am going to do, just a small line here I am drawing. Okay, CO, copy, because this line should be parallel to this one. That is why don't take another line. Okay, let me take it outside, should not be there. Okay, now trim this portion, trim this portion, trim this portion, trim. See, 1 dash we got, 2 dash we got. Similarly, now what I am going to do, instead of move, let me go with copy only. Select this one, CO, copy, 3, 4 and then 5, because these lines are parallel to this one. Now let's take from here to cross here, TR, trim. Perfect. Now from 4, let's take up to 4, TR, trim, cut this one, cut this one, cut this one. Now perfectly we made it. Now from 3, this one, TR, this one, this one, this one. If you don't want anything, just you can remove also. Okay, see how perfectly we got these points. Nothing similar to the previous one, just this line should be parallel to the EF and CD. Now we got this point, empty P1, switch off the ortho, CO copy, 1, 2, 3, 4, 5. P1 is there, P2, P3, P4, P5. Perfect. Let's delete these lines. No need. Okay. Take the spline command. SPL spline. P1, P2. It should pass through P, P3, P4, and P5. Just press spacebar or enter. This is the hyperbola. We got it through oblique asymptotes. LWD, enter on to display the line weight. See, successfully we got this hyperbola. All the lines should be parallel to this one. Now let's mark a point here. This point name, let us name as Ctrl C, Ctrl V for drawing the tangent and normal. Okay, nice. Now exactly to this one, you can draw here. RS. Now DAL, $125 is there, so that's why we can do one thing. PO, yeah. Now bracket point. Okay, I break this one. CO copy from this point to this point. I marked it. Same distance. So now this point PO, yes, Ctrl C, Ctrl V. This is the tangent T point. Now from T to R and in the same direction okay, once again take a line, take a line, okay, we'll do one thing, EX extend, If you see exactly, it passes tangentially to this one. This is the tangent. Applying the blue color. Control C, Control V. This is the T dash. T dash is the tangential point at this curve. You can zoom it and see. Perfectly, it is a tangential only. Done. Now select this point, rotate at this as a base point, rotation angle copy 90 degrees. This is the normal for this one. I don't want this much one for normal, just make it to smaller. This is the normal for the tangent. Control C, Control V, Control V, N dash is the normal and then tangent. So this is how we drawn hyperbola using oblique asymptotes method. Now let's give dimension. Perfectly, we got 70 mm, and coming to this one is 85 mm DAL. See, it is giving 88. Wrong. Why? Because always DAL, it should be perpendicular. This is how you need to mark. 85 mm from this one, 70 mm from this one. That's it, guys. With this, we completed the oblique asymptotes method for constructing a hyperbola.